You know, when you go riding your bicycle, its wheels describe isochronous curves. And what does that mean? Well, imagine you have a piece of white paint on your black tyre. It'll come around, hit the road, stay stationary for a bit, then come up, over, and around and hit the road. And in doing that, it describes an isochronous curve. And it's a very interesting curve with very interesting properties. And I'll show you why. First of all, it's very hard to capture one off a bicycle. So what we have to do is to, at home, create the same sort of conditions for drawing one. First of all, a roadway, which you make out of a ruler, and we will capture the curve on a piece of paper. Everything has to be kept very, very stable, so we stick the whole lot down. Sticky tape everywhere, on the corners of the paper and across the ruler. And that way we can't budge the ruler, even with a fair bit of pressure. And the bike tyre is going to be provided by, well, first of all, the wheel is going to be a tin. This is a tobacco tin with a smooth lid, not a serrated one. And to stop it skidding on the ruler, your roadway, I've put on its own bike tyre. And that's a piece of, already a whole rubber band, which runs around there without any kinks and without any twists. So that it runs along the ruler, doesn't skid, and the whole thing rolls very smoothly. But it doesn't leave a mark. It doesn't draw the isochronous curve. So to do that, you have to cut the point off a piece of, or an old pencil, sharpen it to a point, and just slide that underneath the rubber band, so that the point comes out below the tin lid and will rest on the piece of paper like that. You have to stop it being pushed backwards, and of course sticky tape's the answer there. Lots of it, but don't let it muck up the rubber band. I'll put another one on there just to make sure. So that should hold the pencil in place. The rubber band should stop the thing from skidding on the ruler, and we're ready to draw it. Put it down with that pencil point right next to the ruler, in that position there. It's resting on the ruler. Hold the whole thing steady. Push the rubber band up against the ruler and rotate it the way your bike wheel would roll along the road. Very slow here, but that gives you control, and while you do that, the pencil point comes around, and if you don't skid, will describe a very smooth and beautiful isochronous curve. There it is. Now you can just cut that out. What I did was to trace it onto a piece of acetate, the sort of thing that you use in schools, and project it onto a large piece of cardboard so you can see what's going on. I've cut that out here. It's rather special cardboard in that it's got hard cardboard on either side of a piece of foam, and those are now going to act like tram rails. And I can take a ball bearing and putting it on there, it'll run between those rails up and down the curve. And in fact, it's the way balls run on that curve that give it the name of isochronous, because isochronous means same time. And it's a very peculiar curve because if I let a ball go from any spot here and any spot here, they'll both meet at the midpoint, that red arrow, at exactly the same time, no matter where I release either of them. I'll show you. Here we go. 1, 2, 3, click, and they meet at the arrow. Other curves don't do that. If we had a circle there, or a fraction of a circle, if I let one ball go there, one ball go there, they'd meet somewhere here. And if I put one there, they'd meet somewhere there. They'd meet at different places. But wherever we let these go, on either sides of that, they'll meet, if we let them go at the same time, at the red point. Click, like that. And one last time, I'll let it go near the middle here, and up on the side here. 1, 2, 3, click. Allowing for slight inaccuracies in manufacture. That's not all it does. You'd think that if we let a ball go up at the top here, because it's got a very long way to go around that curve, it would take longer to get to that point than if it took a straight line. But that's not so either. If I put the straight line in, it's another piece of track. I'll just make sure it intersects at that red arrow. And I'll put a finishing line there in the form of a match, across like that. If I come round here and release these two balls at exactly the same point, 1, 2, 3, go. And in fact, the curve wins by quite a distance. And those are just a couple of the very peculiar properties of this most interesting isochronous curve.